أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم يسر ولا تسلطن خير من يرمي. Two-source interference, also known as double-slit interference, occurs when waves from two coherent sources overlap, creating alternating constructive and destructive interference. Variance of two waves can result in a large small wave, a phenomenon of demonstrated using water, sound, light, and microwave. Two sources of interference, also known as double slit, can occur when waves of two coherent sources overlap, creating alternating and destructive interference. Interference of two waves can result in a small large wave. The phenomena demonstrated using water, sound, light, and microwave conditions for observing interference variance. To observe interference variance in our two-source setup, the setup following condition must be met. Coherent sources. Two coherent sources must emit waves and the same frequency and wavelength. Coherent sources must emit wave of same frequency and wavelength maintaining constant phase relationship. The split should be narrow and close, ensuring that the wave of each split overlap and interact with each other. Monochromatic wave. The source should emit wave. The source should emit with a single wave, monochromatic, to create clear interference path. Environment. It's a stable environment. The experiment must be free from disturbance like vibration and air current, which could disturb white pattern and interference with the variance observation. By safety, these conditions to interference variance can be observed across various wave types, demonstrating the wave of natural light, sound, and phenomena. Interference of water. Interference of wave of water. A ripple tank experiment. By satisfying these conditions, two interference variance can be observed across various wave types, demonstrating the. By satisfying these conditions, two source interference variance can be observed across various wave types, demonstrating the wave of natural light, sound, and other wave types and other phenomena. Interference of water. In ripple tank experiment, 2 point source generate ripple in water which produce interference. Tank is illuminated by enhancing visibility. The region where waves reinforce each other, constructive interference produced. The region where waves cancel each other, destructive interference produced. The result of alternating bright and dark variance on the water surface is the result of these interference. The result of pattern of alternating dark the resulting pattern of bright and dark variance on the water surface is a result of these interference. The result of pattern of alternating bright and dark ferrigens on a water surface is the result of these interference. The resulting pattern of bright and dark of alternating bright and dark ferrigens on the water surface is the result of these interference. The resulting pattern of alternating bright and dark ferrigens of the water surface is the result of these interference of two wave source 1 source 2 wave if two wave arrive in phase, these series and torque arrive at equal same time. The interference of two sources, the interference of two circular wave sources 1 and 2 phase arrive in phase. Their series or torque arrive at the same time. They will have interference constructively. Interference of two wave source 1 and 2. Interference of two wave source 1 and 2 arrive in a phase which their series and torque arrive at the same time. They will be interfering constructively. The resulting wave will have higher series and deeper torque as deeper torque than the two individual waves. The wave in anti-phase with a phase of pi radian or 180 degree arrive in such way a series of one wave falls on the torque wave, producing torque of the other wave produce destructive interference resulting in a small amplitude. This phase difference is caused by the path difference, which allows different waves to travel distance. In a ripple tank experiment, 2 point source generate ripple in water which produce interference. Tank illuminated to enhance visibility. The region where waves interact reinforce each other. Constructive interference produce the region where waves cancel each other and destructive interference occur. The resulting pattern of alternating bright and dark ferrigens of the ferrigens on the water surface is the result of interference of two circular waves. So 1 and 2 arrive if two phase arrive in a phase, their series of torque, their series and torque arrive. Their series and torque arrive at the same time. They will have interference constructively. The resulting wave will have higher series and deeper torque than two individual waves. Anti-wave is produced is anti-wave wave in anti-phase with a phase of pi radian or 180 degree arrive at such way that series of one phase falls on torque series of one phase falls on torque of other wave produce destructive interference fall through on torque of other phase falls on the torque of other wave falls on torque of other phase produce destructive interference resulting in small amplitude. This phase is different. The phase in antiphase wave in antiphase with a phase of different pi radian and 180 degree arrive in a such way where their series of one wave falls on torque of other wave produce destructive interference resulting in a small amplitude wave. This phase difference is caused by different pattern. The resulting in small amplitude, the resulting in smaller amplitude wave, 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 the resulting in smaller the wave in antiphase which the phase difference of pi radian or 180 degree arrive in such way that series of one wave falls on torque of other wave producing destructive interfere resulting small amplitude wave resulting in small amplitude wave resulting in small amplitude resulting in small amplitude wave resulting in small amplitude. These phase difference this phase difference is caused by the path difference. This wave difference is caused by 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 path difference, which allowed a different wave to travel different distances. This phase difference is caused by path difference. This wave difference is caused by path difference. Wave difference is caused by path difference. This 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 phase 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 difference caused by path difference, which allow different wave to travel different distance. This phase difference is caused by path difference, which allows wave to travel different path. ठीक है. This phase difference cause the path difference, cause path difference, which allows the wave to travel different, which allow different wave to travel different paths. Alright. Difference of wave, sound wave. Sound interference of sound wave. Sound wave can be exhibit two source interference. Sound wave can exhibit two source interference. wave from both sources overlap. The two source wave from both sources overlap. The two wave sources. The two wave sources. The two wave from both sources. The sound wave exhibit two source interference. Exhibit sound wave exhibit two source interference. The sound wave from source can the sound wave from both sources overlap. The sound wave from both sources overlap, creating region constructive and destructive interference. 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 Sound wave can exhibit two source interference. The sound wave from both sources overlap, creating region of constructive and destructive interference. Sound wave can exhibit two source interference. Sound wave exhibit two source interference. And sound wave can exhibit two source interference. Sound wave exhibit two source interference. Sound wave exhibit two source experiment. Sound wave exhibit two source interference. The sound wave from both sources overlap, creating region of constructive and destructive interference. Sound wave can exhibit two source interference. Sound wave can exhibit EXHI bit, exhibit EXHI bit. Sound wave exhibit two source interference. The sound of both sources overlap each other. Both sources overlap, creating region of constructive and destructive interference. Interference of sound wave. Sound wave can exhibit two source interference. Exhibit two source interference. The sound wave from both sources overlap, creating constructive and destructive interference. Getting the region. The sound wave can exhibit two source interference. The sound wave exhibit two source experiment. The sound wave exhibit two source experiment. The sound wave can exhibit two source interference. The sound wave can exhibit two source. The sound wave can exhibit two source experiment. The sound wave can exhibit. The sound wave can exhibit two source interference. The sound of both sources overlap, creating constructive and destructive interference. Creating region of constructive and destructive interference. The sound wave exhibit two source interference. The sound of both sources overlap, creating region of constructive and destructive interference. This pattern can be visualized using a microphone or detector of measurement of intensely on a sound at various points of the screen. The pattern can be visualized by using microphone or detector to measure the intensity of the sound at various points of the screen. Intensity of the sound at various points of the screen. The pattern can be visualized. देखा जा सकता है using a microphone or detector to measure the intensity of sound at various point of the screen. The various point of the day, the pattern can be visualized. Using microphone. The pattern can be visualized. VISUALIZED. Visualize करेंगे आज निकाल visualize using microphone or director to measure the intensity of sound at various point of the screen. The sound can exhibit two source interference. The sound of both sources overlap, creating region of constructive and destructive interference. The pattern can be visualized using microphone and detector to measure the intensity of sound at various point of screen. The pattern can be visualized using microphone and detector to measure intensity of sound at various points of screen. The pattern can be visualized using microphone or director to measure the intensity of sound various point of screen. Sound waves from loudspeaker produce sound and sound wave from loudspeaker can produce sound and sound wave from loudspeaker produce sound from same frequency. Constructive interference occurs when compression or rarefaction align making louder sound. ALIGN align, rarefaction align making louder sound. I would suggest writing it. Sound from loudspeaker produce sound from same frequency. Constructive interference occur when compression or rarefaction align making the sound louder. Okay. Interference of sound wave. Interference of sound wave Interference of sound wave. Okay. Sound wave can. Okay. First of all, sound wave exhibit exhibit two sources sound of both sources sound of both sources sources overlap, creating region of constructive and destructive and destructive interference two source interference destructive interference. Destructive interference, full stop. The pattern P-A-T-T pattern of sound interference of sound wave exhibit two source interference and sounds of two sources overlap, creating constructive and destructive interference pattern of both sources pattern of both sources pattern can pattern can be visualized. Pattern can be visualized by microphone by using microphone MICROPHONE phone microphone and I don't know आगे बोल microphone and detector DEC detector measuring the intensity of measuring the intensity, measuring the wave of measuring the intensity of sound, measuring the intensity of sound आगे भी आएगा था ना, measuring the intensity of sound at various points of the at VARIOUS various point the various point of the screen. Sound wave from loudspeaker produce same frequency sound waves from loudspeaker from LOUD loudspeaker SPEAKER speaker produced sound of same frequency frequencies same frequencies. Sound from loudspeaker produce sound of same frequencies. Constructive interference occurs when compression of rarefaction aligns ALIGN aligns, making sound louder. LOUDER. Destructive frequency interference occur. Destructive frequency interference occur OCCURS when compression aligns ALIGN align with rarefaction causing quieter sound. QUIETER quieter sound. This principle 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 is used in noise cancellation headphone Sound wave can exhibit two source interference. The sound of both sources overlap, creating region of constructive and destructive frequencies. constructive and destructive interference. Sound will exhibit two source interference. The sound wave from both sources overlap. The sound wave from both sources overlap, creating region of constructive and destructive frequency. Region of constructive and destructive sound wave can exhibit two sources interference. The sound wave from both sources overlap, creating region of constructive and destructive interference. Sound wave can exhibit two sources interference. The source wave from both sources overlap, creating constructive and destructive interference. The pattern can be visualized using microphone or detector to measure the intensity of sound at various point of screen. Sound wave from loudspeaker produce sound from same frequency. Brain fog. Fuck me. Sound wave from loudspeaker produce sound of same frequency. Sound of same frequency. Sound wave from loudspeaker produce 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 same frequencies sound produce sound of same frequencies. Constructive interference occur when compression and rarefication aligns, making sound louder. Destructive by quieter बनाते हैं क्योंकि same way constructive interference occur when compression or rarefication aligns, making sound wave from loudspeaker produce sound wave from loudspeaker produce pattern. Sound wave from loudspeaker produce sound of same frequency. Sound wave from loudspeaker produce sound of same frequencies produce sound wave from loudspeaker produce sound from same frequencies. Sound of same frequency. Constructive interference occur when compression or rarefication aligns, creating louder sound, making the sound louder. Sound wave from loudspeaker produce sound of same frequency. Sound wave from loudspeaker produce sound of same frequency. Sound wave from loudspeaker produce sound of same frequency. Sound wave from loudspeaker produce sound of same frequencies. Constructive and destructive interference occur when compression or rarefication aligns, making the sound louder. Sound wave from loudspeaker produce sound of same frequency. Sound wave from loudspeaker produce sound of same frequency. Constructive interference occurs when compression or rarefication rarefication align, making the sound louder. Destructive interference occurs when compression aligns with rarefication, causing sound louder. This principle is used in noise cancelling headphones. Destructive interference occurs. Destructive interference occurs. Sound wave from loudspeaker produce sound of same frequency. Constructive interference occur when compression or rarefication align, making the sound louder. Destructive interference occur when compression aligns with rarefication, causing quieter sound. This principle is used in noise cancelling headphones. What I like is the sound wave occur. Sound wave. Sound wave exhibit sound wave exhibit sound wave exhibit two source interference to source interference the sound of both sources the sound of both sources overlap creating region of constructive and DES truck divergence destructive interference. The pattern can be visualized. The pattern can be visualized by microphone and detector to measure measure the intensity of sound. Measure the intensity of sound at various points of the screen. of SCREE in screen, various point of screen. आगे आता है, आगे बड़ा इंटरेस्टिंग, the sound from the sound waves from loud speaker, the sound of loudspeaker produce produce sound of same frequencies, frequencies, comma, the constructive interference occur occurs when the constructive interference occur when, I don't know, the constructive interference occur when, I don't know, think about it. The constructive interference occur when compression, or rarefaction align making sound louder, louder, louder. The destructive interference occur when compression align with I don't know, probably align with rarefaction making sound quieter, quieter. This occurs occurs when I don't know, this principle principle used in noise cancelling cancelling headphone interference of light wave, a double slit interference used in a laser beam. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم يسر والصلاة من خير آمين يا رب العالمين. Sound wave can exhibit two interference. The sound wave from both overlap, creating region or constructing and destructing interference. The spectrum can be visualized using microphone or director to measure the intensity of sound at various points of the screen. Sound wave from a loudspeaker produce sound of same frequency. Constructive interference occur when constructive interference occur when compression of ramifications align making the sound, or destructive interference occurs when compression aligns with the ramification causing the sound. This principle is used in noise cancellation headphones. Interference of light wave. A double slit experiment used a laser beam as coherent light source. A light beam is directed through a narrow split to create two coherent light waves. This pattern consists of alternating bright and dark frequencies, which can be observed on the screen directly or captured using camera. Monochromatic light passes through the vertical slits double slits, creating a diffraction pattern on the screen, resulting in a multiple bright and dark lines spread horizontally. Without diffraction and interference, the light would be simple and two lines on the screen. A double split interference used as a laser beam as a coherent light source. A double split experiment uses a laser beam as a converter light source. A double split experiment uses a laser beam as a coherent light source. A double split experiment uses a laser beam as coherent light source. A double slit experiment uses coherent light source. A double split experiment uses a laser beam as coherent light source. The light beam is directed through two narrow slits to create constructive coherent light wave. A double slit experiment uses a light beam as a coherent light source. A double slit experiment uses a light beam as coherent light source. A double slit experiment uses a light beam as a coherent light source. A double split experiment uses double split slide experiment uses a double slide slide uses two coherent sources. Uses laser beam as two coherent light sources. Double slit experiment uses laser beam as two coherent light sources. Uses laser beam as two coherent light sources. Laser beam as two coherent light sources. What the? for the dark. A double slit experiment uses laser beam as coherent light source. A double beam experiment uses coherent light source. A double beam experiment uses a double slide experiment. A double slide experiment uses coherent. A double slide experiment uses laser beam as coherent light source. As a coherent light source. As coherent light source. Coherent light source. Light source. A double slide experiment uses a laser beam as coherent light source. As a coherent light source. A double slide experiment uses laser beam. A double slide experiment uses laser beam. A double slide experiment uses laser beam as coherent light source. A double slide experiment uses a double slide experiment uses coherent light source. A double slide experiment uses coherent light source. A double slide experiment uses coherent light source. A double slide experiment uses laser beam as laser beam. Use a laser beam as coherent light source. Coherent light source. The laser beam is directed towards two narrow slide to create coherent light wave slit. A double slit experiment uses laser beam as coherent light source. The laser beam is directed towards two narrow slide slit to create two coherent light wave. The laser beam is directed through two narrow slit to create two coherent light wave. The light beam is directed through two narrow slit to create two coherent light wave. The light beam is directed through two narrow slit to create coherent light wave. But the light beam is directed through two narrow slit to create a coherent light source. The light beam is directed through two narrow slide to create two coherent light wave. Light beam is directed through two narrow slide to create two coherent light sources, two coherent light wave. The light beam is directed through two narrow slide to create two coherent light wave. A double slit experiment uses laser beam as coherent light source. The light beam is directed through two narrow slide to create two coherent light source. A double slit experiment uses laser beam as two coherent source. The laser beam directed through through two narrow slit to create two coherent light wave. Two coherent light wave. The pattern consists of alternating bright and dark figurines which can observe on screen directly to capture using a camera. The laser beam is directed through two narrow slit, creating a coherent light wave. Two coherent light wave directed through narrow slit. to create coherent light source, two narrow lights to create two coherent light source. Goddamn dignity. A double slide experiment uses laser beam as two coherent light sources. The laser beam is directed through two narrow split, creating two coherent light wave. Two coherent light wave. The pattern consists of alternating bright and dark variation, which can be observed on the screen directly or captured using camera. A double slit experiment uses laser beam as a coherent light source. The light beam is directed through two narrow split, two narrow so creating two coherent light sources. A double slit experiment uses laser beam as coherent light source. The light beam is directed through two narrow slits to create two coherent light sources. The pattern consists of alternating bright and dark variants. Creating constructive and destructive variants. A double slit experiment uses laser beam as two coherent sources. The laser beam is directed through two narrow split, creating two coherent light wave. The pattern consists of alternating bright and dark variants, which can be observed on the screen directed on a captured. The pattern consists of alternating bright and dark variants, which can be observed on the screen directly on a capture. Using a camera. The light beam is directed through narrow split to create two coherent light waves. The pattern consists of alternating bright and dark variants. The pattern consists of alternating bright and dark variants. The pattern consists of alternating bright and dark variants. The pattern consists of alternating bright and dark variants, which can be observed on the screen which can be observed directly on the screen or using camera. A double slit experiment uses the laser beam as coherent light source. The light beam is directed through narrow split, creating two coherent sources. A double slit experiment uses laser beam as two coherent sources, creating constructive and destructive. Light beam is directed towards narrow split to create two coherent sources, two coherent light wave. The pattern consists of alternating bright and dark variants, which can be observed on the screen directly or captured. A two-split experiment uses laser beam as coherent light source. The light beam is directed through narrow split, creating two coherent light waves. The pattern consists of alternating bright and dark variants, which can be which can be observed on screen directly or captured using a camera. A double slit experiment uses laser beam as a coherent light source. The coherent light source The split experiment uses laser beam as coherent light source. The laser beam is directed through a narrow slit creating two coherent light waves. The pattern consists of alternating bright and dark frequencies, which can be observed on the slit directly or using camera. Monochromatic light passes through virtual split, creating a diffraction pattern. Diffraction pattern on the screen, creating a resulting in a two-split experiment uses laser beam as coherent light source, which the light beam is directed through two narrow split to create two coherent light waves. The pattern consists of alternating bright and dark frequencies, which can be observed on the screen directly using capture, which can be observed on the screen directly, which can be observed directly on the screen, or can be captured using camera. Monochromatic light passes through virtual slide. The light passes through virtual slide. Monochromatic passes through light passes through virtual slide. Monochromatic passes through virtual slide, creating a diffraction pattern on the screen. Monochromatic light passes through virtual slide, creating a diffraction pattern on the screen, resulting in multiple bright and dark spread horizontally. Monochromatic light passes through virtual split. Monochromatic light passes through virtual split, creating a diffraction pattern on the screen, creating a diffraction pattern on the screen. Monochromatic passes through virtual slide, creating diffraction pattern on the screen, creating a diffraction. Resulting in multiple bright and dark line spread horizontally, resulting in multiple bright and dark light spread horizontally, resulting in multiple bright and dark light, spread horizontally without differentiation, and interference. Without diffraction and interference, the light would simply make two lines on the screen. Without diffraction or interference, the light would simply make two lines on the screen. Mono. Can you write it? Sure. Light interference of light. A double-slit experiment also uses light beam as coherent light source. A light beam is directed through narrow slit grating constructed two coherent light sources. The pattern consists of alternating bright and dark fluorescence, which can be observed on the screen directly using capture. A double-slit experiment uses laser beam as coherent light source. The light beam is directed through narrow slit grating constructed and resistive fluorescence grating. A double-slit experiment uses two coherent sources and uses laser beam as two coherent sources. The light beam is directed through two narrow slit grating two coherent light source. The pattern consists of alternating bright and dark fluorescence, which can be observed on the screen directly or captured using camera. Monochromatic pattern on the screen result in monochromatic light passes through monochromatic light passes through virtual slide. Monochromatic light passes through virtual slide, creating diffraction pattern on the screen. Creating a diffraction pattern on the screen, creating a diffraction pattern on the screen. Monochrome light passes through pattern. Light passes through virtual slide, creating a pattern. Diffraction pattern, creating a diffraction pattern on the screen, creating a diffraction pattern resulting in bright and dark lines spread horizontally without diffraction or interference. The light would simply make two lines on screen. Double-slit experiment. Interference of light wave. Interference of light wave. consists double slit experiment Con uses what? Double slit experiment uses, I don't know. Or search. I really don't know. Laser beam through directed through as two coherent light sources the laser beam is directed. The LAZ laser beam is directed through two narrow split. Okay, I get it. Narrow split creating bright and dark fergens comma can be visualized on the screen, RWM screen, or capture using camera monochromatic light passes through monochromatic light passes through virtual light VETURAL virtual SLIT slide, creating creating a pattern, a PATT pattern that consists pattern, diffraction pattern, diffraction pattern consists on the diffraction pattern on the SCREEN screen, comma split multiple bright and dark, bright and DARK, dark light, LIHT light, multiple bright and dark light, bright and dark light, bright and dark lines, bright and dark line, bright and dark line spread horizontally, SPREAD spread horizontally, comma without diffraction, without diffraction or diffraction and interference. Like simply make two line on the screen. A double split experiment uses a laser beam as two coherent light source. The light beam is directed through narrow split, creating coherent light wave. The pattern consists of alternating bright and dark frequencies which can be observed on the screen directly, which can be observed on the screen directly, which can be observed on the screen directly, which can be observed on the screen directly. Which can be observed on the screen directly or captured using a camera. Monochrome light passes through virtuous side. Monochromatic light passes through virtuous light, creating a diffraction pattern on the screen, resulting in multiple bright and dark horizontal split. Bright and dark, resulting in multiple 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 bright and dark fragments, resulting in multiple bright and dark fragments. Monochromatic light passes through virtuous light, creating a diffraction pattern on the screen, creating a monochromatic light passes through virtuous light, creating a diffraction pattern on the screen, result in multiple bright and dark light spread horizontally, resulting in multiple bright and dark frequencies. Resulting in multiple bright and dark spread horizontally without diffraction and interference. The light would simply make two lines on the screen. Okay. Thomas Young double slit experiment. Describe Thomas Young's double slit experiment and the evidence it provides support on the wave theory and light. In 18 Thomas Young theory के बारे में. Okay. Thomas Young theory. Next page. Thomas Young theory. Thomas Young theory. In 1801, Thomas Young performed the interference experiment to prove the wave natural light. Young's double slit is evidence for the wave natural. A screen having two narrow slits to illuminated by beam of monochromatic light. Double slit experiment. Thomas Young, Young's double split experiment, DOUBLE slide experiment, experiment. Slide experiment. In 1801, Thomas Young performed interference. In 1801, Thomas Young performed interference to prove double slit experiment. Thomas Young performed to prove double slit experiment. In 1801, Thomas Split performed the interference experiment. The interference experiment to prove the natural wave of light. Thomas Split performed double slit experiment to prove natural wave of light. In 1801, Thomas Split performed the natural paradigm experiment to prove the wave of light. To prove the wave of natural light. To prove the nature of light. To prove the nature of light. In 1801, Thomas Young performed the interference experiment to prove the nature of light. In 1801, Thomas Young performed the interference experiment. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. experiment to prove the wave of natural light in 1801. Thomas Young performed in 1801. Thomas Young performed interference experiment to prove the natural wave of light, to prove the wave of natural light, to prove the wave of natural light, to prove the wave of natural light. Thomas Young in 1801. Thomas Young performed experiment in 1801. Thomas Young performed experiment. Thomas Young performed the interference experiment to prove the wave of nature of light. The wave nature of light. In 1801, Thomas Young performed the interference experiment to prove the wave nature of light. Young's double slit is the evidence of the wave natural split. In 1801, Thomas Young performed the performance. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light, the wave of nature of light. Young's double split is the evidence for natural wave. In 1801, Thomas Young performed the interference experiment to prove the wave of light, to prove the wave of natural light, In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. In 1801, Thomas Young performed the interference experiment. In 1801, Thomas Young performed the interference experiment to prove the wave of nature. To prove the wave nature of light, Thomas Young double slit is the evidence of natural wave. Thomas Young double slide is the experiment. Thomas Young double slide. Thomas Young's double slide is the experiment. Thomas Young double slide is the evidence of natural wave. A screen having two narrow slides to illuminated beam of monochromatic light, illuminated by a beam of monochromatic light. In 1801, Thomas Young performed interference experiment. In 1801, Thomas Young performed interference experiment. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. Young's double slide is the evidence of natural wave. Young's double slide is the wave. In 1801, Thomas Young performed interference experiment to prove wave nature of light. Young's double slide is the evidence of natural wave. Young's double slide is the evidence of natural wave. A screen having two narrow slits to illuminated by the beam of monochromatic light. In 1801, O1 Thomas Thomas Young perform perform the interference experiment to prove wave nature of light split light nature of light Young's double slide double double slide is the evidence for wave nature and nature a screen having having two narrow split, two narrow slides slides is illuminated by a beam of monochromatic light. In 1801 Thomas Young performed the interference experiment to prove the wave of natural frequency. In 1801, Thomas Young performed In 1801, Thomas Young performed interference experiment to prove the wave of natural light. Young's double slide is evidence for natural wave. A screen of having narrow slide is illuminated by a beam of monochromatic light. In 1801, Thomas Young performed interference experiment to prove the wave of natural light. Nature of light. Young's double slide is the evidence of natural wave. Young's double slide is evidence for wave nature. A screen having two narrow split is illuminated by a screen having two narrow slides. A screen having two narrow slides. A screen having two narrow slides is illuminated by a beam of monochromatic light. A screen having two slides is illuminated by beam of monochromatic lights. Illuminated by monochromatic lights. a screen having monochromatic a screen having two narrow slides illuminated by a beam of monochromatic light. In 1801, Thomas Young performed the interference experiment to prove the wave of nature light. Thomas Young's double slide evidence for wave of nature light wave nature a screen having two narrow slides is illuminated by beam of monochromatic light. In 1801, Thomas Young performed the interference experiment to prove the wave of nature light. Young's double slide interference is evidence for wave nature, a screen having two narrow slides is illuminated by a beam of monochromatic light. A screen having two narrow slides is illuminated by beam of monochro light. A screen of having two narrow slides is illuminated by a beam of monochromatic light. A screen having two narrow slides illuminated by a beam of monochromatic light. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. To prove wave of nature light. Young's double slide is evidence for wave light, wave nature. A screen having two narrow slides is illuminated by a beam of monochromatic light. A screen having two narrow slides is illuminated by a beam of monochromatic. A screen having two narrow slides is illuminated by a screen having two narrow slides is illuminated by beam of monochromatic light. The principle of this experiment is based on the division of front wave. The principle of the experiment is based on division of wave. The principle of this experiment is based on division of wave front. The principle of this experiment is based on the division of wave front. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. Young double slit is evidence for wave nature. A screen having two narrow slides is illuminated by a beam of what? Beam of monochromatic light. The principle of the experiment is based on division of front wave. The principle of this experiment is based on division of front of wavefront. The principle of this experiment is based on division of Young front. The principle of this experiment is based on division of Young wavefront. Is based on the principle of this experiment is based on the principle of this experiment. The principle of this experiment is based on division of wavefront. Is based on division of wavefront. The principle of this experiment is based on division of Young front. The principle of this experiment is based on division of Young front. The principle of this experiment is based on division of Young front. The principle of this experiment is based on division of wavefront. In 1801, young Thomas performed an interference experiment to prove the natural wave of. In 1801, Thomas Young performed the interference experiment to prove wave of nature light. Young's double slide is evident for wave light, a screen having two narrow slide, 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 a screen having two narrow slides, to illuminated by beam of monochromatic light. The principle of the split the experiment is based on division of front wave. The principle of this experiment is based on the principle of the experiment is based on the principle of the experiment is based on the principle of this experiment is based on the principle of this experiment is based on the principle of this experiment is based on division of wavefront. The principle of this experiment is based on division of wavefront. The principle of this experiment is based on division of wavefront. The principle of this experiment is based on division of wavefront. The principle of this experiment is based on the principle PRINCIPLE. Principle of this experiment per month is based on division division of wavefront. Monochromatic light. The principle of this experiment The principle of this experiment, the principle of this experiment is based on the division of wavefront. In 1801, Thomas Young performed the experiment of the interference experiment to prove nature wave of nature light. Thomas double slide is the evidence of wave nature. The screen of two narrow slide is illuminated by beam of monochromatic light. The principle of this experiment is based on division of wavefront. Monochromatic light passes through a narrow slide produced by semicircular wave. Monochromatic light passes through two narrow slides, produce semicircular wave. Semicircular wave that overlap and interfere on a screen placed behind the slide. That overlap the monochromatic light passes through narrow slide, produce semicircular wave. The monochromatic light passes through narrow slide. The monochromatic light passes through narrow slide. The monochromatic light passes through narrow slide. The monochromatic light passes through narrow slide, produce semicircular wave. Semicircular wave that overlap and interfere on the screen behind the slide. Monochromatic light passes through two narrow slide produce semicircular wave that overlap and interfere on the screen behind the slide. Place behind the slide. Monochromatic light passes through. Monochromatic light passes through. Monochromatic light passes through two narrow slide, produce semicircular wave that overlap and interfere on the screen placed behind solid. Monochromatic light passes through. Monochoro light passes through two narrow slides. Monochoro light passes through two narrow slides, produce semi-wave that overlap and interfere on Monochromatic light passes through two narrow slides. Monochromatic line passes through two narrow slides. Monochromatic light passes through two narrow slides. Monochromatic light passes through two narrow slides. Two narrow slide. Produce semicircular wave. Producing semicircular wave that overlap and interfere on a screen placed behind the slide. The monochromatic light light passes the monochromatic light passes passes through wavelength. The monochromatic light passes through two narrow slide, two narrow slides, slides, two narrow slides, producing producing I don't know, कुछ हमने गलत लिखा है. Producing monochromatic light passes through two narrow slides, producing monochromatic light passes through two narrow slides, producing semicircular. ये मुझे खुद भी याद नहीं आ रहा था. circular wave, waves, wave, that overlap and interfere on a screen behind the slide, behind the slides, behind the slide, placed behind the slide. monochromatic light passes through two narrow slides producing semi-circular wave. The overlap interfere on behind place. Control mic. Monochromatic light passes through two narrow slides producing semicircular waves that overlap and interfere on the screen placed behind the slides. Monochromatic light passes through two narrow slides. Monochromatic light passes through two narrow slides producing semicircular wave that overlap and interfere on a screen placed behind the slide. As the two slide S1 source 1 and source 2 S1 S2 source 1 source 2 होते हैं. As the two slide S1 and S2 are narrow, so the light spreads out diffract from each slide. Diffract from each side. Source 1 and 2. Okay. Two slide generate shit. Two another slide. Okay. As two slide source 1 and 2 S1 and 2 narrow. The S2 narrow slide S1 and S2 are narrow, so the light spreads out diffracted from each slide. The two narrow slide. S2 slide S1 and 2 are narrow. S2 slide S1 and 2 are narrow. S2 slide S1 and 2 are narrow, so the light spreads out diffracts as the two slide S1 and 2 are narrow, so the light spreads as the two slides S1 and 2 are narrow, so the light S2 slides S1 and 2 are narrow. S2 slide S1 and 2 are narrow. S2 slide S1 and 2 are narrow. S2 slides S1 and S2 are narrow. ठीक है, narrow है. So the light spreads out. Diffracts from each slide. So the light spreads out diffract from each slide. Two slides generate two coherent light sources, causing interference. Two slides generate two coherent light sources. Two slides generate two coherent light sources. All right. Two slides generate two coherent light sources. ठीक है, causing interference in a coherent bright constructive interference and dark destructive interference pattern on the screen. As the two slides S1 and S2 are narrow, comma, the light S2 slides S1 and 2 are narrow, so the light 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 spreads out SP spreads out diffract from each side slides SLITS slides, comma, the two narrow slide generate generate two narrow in a double R narrow split. Two narrow slides generate two coherent light source, comma, causing interference causing interference in the form of bright bright constructive interference and dark pattern on the screen. S2 slides S1 and S2 are narrow, so the slide to the as the two slide S1 and S2 are narrow, as the two slide S1 and S2 are narrow, as the two slide S1 and S2 are narrow, as the two slide S1 and S2 are narrow, as the two slide S1 and S2 are narrow, comma, so the light spreads out, diffract from each side, so the light spread diffract from each side, so the light spreads out diffract from each side, so the light spreads out the S2 slide S1 and 2 are narrow, so the light spreads out diffract from each side, S2 slide S1 and S2 are narrow, so the light spreads out diffract each slide, two slides generate two coherent light source, causing interference fringes friends in the as two slides S1 and S2 are narrow, so the spread to the light spreads, so the light spreads out as the light spreads as the two splits, so S1 and S2 are narrow, so the light spreads out DIFRAC diffracts from each slide. Two narrow slides generate two coherent light sources, causing interference variance in the form in the form. He lives there. Fine. छोटा सा so the light diffract के आगे क्या आता है? I don't know. Shut the fuck up. Diffract from each other from each slide. Each slide. Two narrow slide, two NARR narrow slide. Two narrow slide, comma के आगे क्या है? Two narrow slide, I don't know. Two narrow slide generate two narrow slide generate two coherent source SOURCE causing 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 interference interference in the bright and dark pattern on the screen. Okay. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ربي يسر ولا قوة إلا بالله Thomas Young double slit experiment. In 1801, Thomas Young performed the interference experiment to prove the wave of nature of light. Young's double slit is the evidence for the wave nature. A screen having two narrow slits is illuminated by a beam of monochromatic light. In 1801, Thomas Young performed. Thomas Young performed the interference experiment to prove the wave of nature of a light. Young's double slide is the evidence for the wave nature. A screen having two narrow slides is illuminated by beam of monochromatic light. The principle of the experiment based on division of wave front. The monochromatic light passes through two narrow slides, producing semicircular wave. The overlap and interference on the screen placed behind the slide. In 1801, Thomas Young performed the interference experiment. In 1801, Thomas Young performed. In 1801, Thomas Young performed the interference experiment to prove the wave of nature of light. The wave nature of light. Young's double slide is evidence for nature light. Wave nature, a screen which having two narrow slits is to illuminate by beam on monochromatic light. The principle of this experiment is based on division of wave front. Monochromatic light passes through two narrow slides, producing semicircular wave that overlap and interfere on the screen behind the slides. In 1801, Young Thomas in 1801 Young Thomas performed the interference experiment to prove the wave of nature of light. Young's double slide is evidence of wave nature, seen. A screen having two narrow slides is illuminated by a beam of monochromatic light. In 1801, young Thomas performed the interference experiment. In 1801, young Thomas performed the interference experiment to prove the wave of nature of light. Young Thomas double slide is the evidence of the nature. A screen having two narrow slits is illuminated by a beam of monochromatic light. In 1801, young Thomas Young performed the experiment of Young Thomas performed the interference experiment to prove the wave nature of light. The Young's double slide is evidence for wave nature wave nature, a screen having two narrow split which is illuminated by a beam of monochromatic light. This experiment, this principle of this the principle of this experiment is the division of wavefront. Based on division of wavefront, monochromatic light passes through two narrow slides, producing semicircular waves that overlap and interfere on the screen behind the slide. Monochromatic. Amen. Monochromatic light passes through F1, F2. Alright. You know the fucking fool. Astaghfirullah. Shit. I'm fucked. Oh, shit. Oh, shit. Okay. Distracted on 8 minutes, sorry. In 1801, Thomas Young performed the interfering experiment to prove the wave of nature of light. Young's double slide is the evidence for the nature. A screen having two narrow slits is illuminated by the beam of monochromatic light. The principle of this experiment is based on the division of the wavefront. The monochromatic light passes through a two narrow slide, producing semicircular waves that overlap and interfere on a screen placed behind the slide. In 1801, Thomas Young performed the interfering experiment to prove the wave of nature of light. Young double slide is the evidence for the nature. A light having two narrow slides is illuminated by beam of monochromatic light. The principle of this experiment is based on the vision of wave front. The monochromatic light passes through the narrow slide, producing semicircular waves that overlap and interfere on a screen behind the slit. Monochrome light passes through two narrow slides, producing semicircular waves that overlap and interfere on a screen placed behind the slide. The monochromatic light passes through two narrow slides. The monochromatic light passes through two narrow slides, producing semicircular waves that overlap and interfere on a screen placed behind the slide. The monochromatic light passes through two narrow slides, producing semicircular waves that overlap and interfere on a screen placed behind the slide. Interfere on a screen placed behind the slit. The monochromatic light passes through two narrow slits, producing semicircular waves that overlap and interfere on a screen placed behind the slit. Monochromatic light passes through two narrow slides, producing semicircular waves that overlap and interfere on a screen placed behind the slide. As the two slides S1 and S2 are narrow, so the light spreads out, diffract from each slide. Diffract as the two slide passes through. As the two slides S1 and S2 are narrow, the light spreads out, diffracted from each. The light spreads out. As the two slides S1 and S2 are narrow, as the two slides S1 and S2 are narrow, so the light spreads out, diffract from each slide, so the light spreads out, diffract from each slide. Two slides generate two coherent lights, so two narrow light source, so causing interference in Farigans from the bright constructed interference and dark destructive interference produce pattern on the screen. As the two slides S1 and S2 are narrow, so the light spreads out, diffracted from each slide. So the light spreads out. Diffract from each side. As the two slides S1 and S2 are narrow, so the light spread out, diffract from each slide. As the two slides S1 and S2 are narrow, so the light spreads out, diffracted from each side, diffracted from each slide. As the two narrow S2 slide S1 and S2 are spread out, the light source, so the light spreads out, diffracted from each side from each slide. The two slides generate two coherent light source, causing interference Farigans in the in the form of a bright constructive interference and dark destructive interference pattern shown on screen. Pattern on screen. Okay, yeah, why not? Thomas Young. Thomas Young. Young. In 1801, Thomas Young performed the interference experiment. The interference experiment meant to prove wave nature of LIGHT Young's double slit slide Young double slide Young double slide Young's double slit is evidence evidence of wave nature. A screen of two narrow slide is illuminated illuminated on the screen, illuminated by beam of monochromatic light. The principle of this experiment. The principle principle of this experiment is based on division division of wavefront the monochromatic passes through a narrow slit. Monochromatic light passes through narrow slit. Monochromatic light passes through two narrow slits producing PRODUCING, producing semi-circular CIRCULAR circular wave, semi-circular wave which can be displayed behind the slide, can be shown behind the slide. आगे क्या आता है? The S क्या कहता है? The two slit slit S1 and S2 are narrow. Two slits are narrow. So the light diffract each other two split slide generate generate two narrow slide generate two coherent light sources LIGHT light SOURCES sources, two coherent light sources causing interference variance CAUSING causing interference variance that is bright constructive interference and destructive interference and dark show bright interference and diffractive pattern on the screen. Kind of work, okay. Thomas Young. In 1801, Thomas Young performed the interference experiment to prove the wave of nature of light. Young double slide is evidence of the wave nature. A screen having two narrow slides is illuminated by a beam of monochrome light. The principle of this experiment is based on division of wave front. The monochromatic light passes through two narrow slides, producing semi-wave that overlap and interfere on a screen placed behind the slide. That overlap and interfere on a screen placed behind the slides. As two narrow slides S1 and S2 two slides S1 and S2 are narrow, so the light spreads out, diffracting from the so the light spreads out boolean. So the light spreads out, so the light spreads out, diffracting from each slide. Two slides generate two coherent sources, causing interference in the form of bright constructive interference and dark destructive interference pattern on the screen. Pair difference from the wave S2 the wave difference, path difference. The wave from S2 slide, the wave from slide S2 travel slightly larger, the slightly larger than from slide S1 to reach the point P, the surface on the screen. The difference in the distance is different path. The phase difference between two wave potential to the path difference expressed in terms of wavelength. Wave is wavelength. Lambda एक half length. Lambda separation distance between two slide AB is equal displacement. D, the distance between the slide of and the screen. L, the distance of a point P from the central maximum on the screen. Y. Okay, ये खुद लिखना पड़ेगा, लिख के समझना है. Difference pair difference path D I double F E R E N C E difference the wave from SLIT slide S2 has to travel travel slightly longer distance. SLIGHTLY slightly longer. DISTANC distance slightly larger या longer distance. Then from slide S slide 1, which is slide 1, to reach the point P on the screen. 2, REACH, reach the point pi on the screen. P on the SCREEN screen. The difference, the DIFFERENCE difference in the distance is the path difference the waveform slide S1 and S2 has to travel path difference. The wave from slide S1 has to travel slightly larger than from the slide 2 has to travel slightly larger than from slide S1 to reach the point P on the screen. You can make it over here if you like. S1 even longer. S2 alright, ये हो गया. ओके, ये यहाँ कर देते हैं. P ये सेंटर है, तो ये O है, ठीक है. डिस्टेंस okay, this is 2 distance, S1 and S2. S2 राइट, ये भी हो गया, ठीक है. A B C, okay. थीटा, ये थीटा हो गया. ये भी थीटा हो गया. और ये एंगल C, राइट एंगल, और ये हो गया D साइन theta sine theta sine theta sine theta sine theta PATH path distance difference DIFL ठीक है y axis y okay diagram बना रहा हूँ path difference the wave of a slide S1 and S2 the wave difference path difference the wave from slide S1 and S2 has to slightly larger than the wave from S2 has to travel slightly larger than S1 to reach the point P on the screen. The wave from slide S2 has to travel the wave from slide S2 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 to the wave from slide S2 has to travel slightly larger the wave from slide S2 has to travel slightly larger than from the slide S1 to reach the point P on the screen. To reach the point P on the screen. Point P on the screen. To reach the point P on the screen. The wave from slide S2 has to travel slightly larger than from the slide 1 to reach the point P on the screen. The difference of this distance is the path difference. The difference in the distance in this distance is the path difference. The difference in this distance is the path difference. The difference in this distance, yeah I know it sounds more complicated. The difference in this distance is path difference. Get it? The difference in this distance is the path distance. The path of a slide S2 has to travel slightly larger than that from S1 to reach the point P of the screen. The difference of this distance is the path difference. The phase difference DIFFERENCE the phase difference between two sources two waves the phase difference between two waves the phase difference between two waves proportional to the difference between two waves proportional to the path difference to the path difference path difference express express in terms of the wavelength of the wavelength length length lambda aka half-life lambda half-life. The path difference the path difference the phase difference between two wave potential the phase difference between two the phase difference between two the phase difference between the phase difference between two wave the phase difference between the phase difference between the phase difference between the phase difference between two wave potential to the path potential to the path the phase difference between two wave is proportional to the path difference expressed in terms of wave is wavelength wavelength lambda aka half-life. The wave from slide S2 has to travel slightly larger than that from slide 1 to reach the point P on the side. The difference in the distance is the path distance. The phase difference between two potential, the phase difference between two wave, the phase difference between two wave, the phase difference between two wave potential to the path difference is the term of the wave is wavelength half-life. The phase difference between two waves, the phase difference between two waves, the phase difference between two waves proportional to the path difference expressed in terms of wave is wavelength lambda. The phase difference between two waves proportional to the path difference expressed in terms of wave is wavelength. The path difference between two waves proportional the path difference between two waves lambda half-life. The phase difference between two waves proportional to the path difference expressed in terms of wave is wavelength. The phase difference between two waves proportional to the path difference the phase difference between two waves proportional to the path difference the phase difference between two waves proportional to the path difference the phase difference between two waves is proportional to the path difference expressed in terms of the wave is wavelength lambda. The phase difference between two waves is proportional to the path difference expressed in terms of the wave is wavelength. The phase difference between two waves proportional to the path difference the phase difference between two waves is proportional to the path difference difference expressed in terms of wave is wavelength lambda. The phase difference between two waves is proportional to the path difference expressed in terms of wavelength lambda. The separation distance between two slide A and B is equal D. The separation distance between the two slides slides is equal AB is equal D. Okay, AB between two slides is equal D. ठीक है. The distance between slide and the screen is equal L. The distance of point P from the center from the central maximum maximum on the screen is equal Y. Separation distance between two slides A and B is equal D. ठीक है. Can you write it? Path difference. Okay, where are we gonna write? Ready? Path difference. The wave from slide, S2 has slightly, वो पता लंबा होता है, has to travel slightly SLIGHT slightly longer 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 than that from S1 to the on the screen to reach the point P on the screen. The difference between the distance distance is DIFFERENCE, difference path. सही है. The phase of a distance between two waves, proportional to the path difference DIFFERENCE, difference expressed expressed in terms of wavelength lambda. Alright, आगे क्या लिखना है? The separation distance between two slides A, B is equal D. Distance between slides and the screen, between the slide and the screen. सही लिखा था. Slide and SCREEN screen is equal L. ठीक है. Distance between what? Between point P and central maximum is equal Y. Alright, let's put it like this, whatever. Yep, it's quite good. That's alright, okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. I can see. In a Thomas Young double slide experiment in 1801, Thomas Young performed the interference experiment to prove the natural wave of light. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. Young double slide is the evidence of natural wave. A screen having two narrow split, a screen having two narrow slide. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. Young double slide experiment is the evidence for the natural light. A screen having two narrow slides is illuminated by the beam of monochromatic light. The principle of this experiment 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 is based on the division of front monochromatic front wave. The monochromatic light passes through two narrow slides producing semi-wave. Wait a minute, I have to. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. Young double slide is the evidence for the evidence for the wave nature. A screen having two narrow slides is illuminated by in 1801 Thomas performed performed the interference experiment to prove the wave of nature to prove the experiment the wave of nature of light to prove the nature of light. In 1801 Thomas Young performed the interference experiment to prove the wave of nature of light. Young double slide experiment is the evidence of wave nature. A screen having two narrow slides illuminated by monochromatic light is illuminated by the beam of monochromatic light. The principle of this experiment is based on division of wave front. Monochromatic light passes through monochromatic light passes through two narrow slides to produce semi-wave. This overlap monochromatic light passes through two narrow slides producing semi-wave that overlap and interfere on the screen placed behind the slide. Monochromatic light passes through two narrow slides producing semi-circular wave that overlaps on the interface. Monochromatic light passes through two narrow slides. Monochromatic light passes through two narrow slides. Monochromatic light passes through two narrow slides producing semi-circular wave that overlap and interfere on a screen placed behind the slide. Interfere on the screen placed behind the slides. In 1801, Thomas Young performed the interference experiment to prove the wave of natural light. Young's double slide is the evidence of the natural wave. A screen having two narrow slides is illuminated by the beam of a light. The principle of this experiment is based on the division of front wave. Is based on division on front wave. The principle of this experiment is based on the division of wave front. Monochromatic light passes through a narrow slide. Two narrow slides produce semi-wave that overlap and interfere on the on the screen placed behind the slide. As the two slide S1 and S2 monogeometric light passes through two narrow slides, producing semicircular wave. Monogeometric light passes through semicircular. Monogeometric light passes through two narrow slide, producing semicircular wave. Producing semicircular wave. Monogeometric light passes through two narrow slide, producing PRODUCING, producing two narrow slide. Light passes through two narrow slides, producing semicircular waves that overlap and interfere on a screen behind the slide. Monochromatic light passes through two narrow slides, producing semicircular waves which overlap. Monochromatic passes through two narrow slides, producing semicircular wave which overlap and interfere on a screen placed behind the slide. As two slides S1 and S2 are narrow, so the light spreads out and diffracted from S2 narrow slide S1 and S2. 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 As the two narrow slide S1 and S2 are S2 S1 and S2 are S2 slide S1 and S2 are narrow. S1 and S2 are narrow, S1 and S2 are narrow, NARROW, narrow. Two slides narrow, so the light spreads out, diffracting each slide. So the light spreads out, diffracting from each slide, diffracting DIFFRACT, diffract from each slides. Two slides generate two coherent light sources, causing the interference variance in the form of bright constructive interference and dark destructive variance pattern on the screen. Path difference. The wave of S2 has to travel slightly larger than S1 to reach the wave of S1. The wave from slide S1 has to travel slightly larger than that from S2 has the slide S2 has to travel slightly larger than that from S1 to reach the point P of the screen. To reach the point P of the screen. This difference is the difference in the distance is the different path. The difference in the distance is the different path. Phase difference between two waves proportional to the path difference expressed in terms of the wave is the wavelength lambda. The phase difference between two waves proportional to the path difference proportional to the path difference. The phase difference between two waves proportional to the path difference. The phase difference between two waves proportional to the path difference expressed in terms of wavelength. Wave is wavelength lambda. The phase difference between two sources the phase difference between two sources. The phase difference between two sources S1, the phase difference between two waves proportional to the path difference expressed in terms of the wavelength. In terms of the wavelength, the phase difference between two sources. The phase difference between two sources. Wave. The phase difference between two waves proportional to the path difference expressed in terms of wavelength is wavelength. The phase difference between two sources. 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 The phase difference between two wave proportional to the path difference. Proportional to the path difference. Proportional to the path difference. The phase difference between two waves proportional to the path difference expressed in terms of wave is wavelength. Proportional expressed in terms of wave is wavelength. Wave is wavelength. Separation between two slides A, B is equal D. Distance between slide and the sequence L. Distance between point P and the center maximum sequence Y. Drawing a perpendicular from A to on B. Draw a perpendicular from A on BP, A on BP, AP is equal CP कहाँ है AP AP is equal CP. AP is equal CP. Therefore, BCA, the draw perpendicular from A on BP, A on BP, the draw perpendicular from A on BP, draw perpendicular from A on BP, draw perpendicular from A on BP. AP is equal CP. From BC, the BC, therefore BC is the path difference between two waves. From delta ABC is equal sin theta is equal BC by AB. Draw perpendicular AB. Draw perpendicular from A on B. Draw perpendicular from A on BP. Draw a perpendicular from A on BP, A on BP, AP is equal CP. Draw a perpendicular from A on BP. The AP is equal CP. Therefore CP. Therefore BC. Therefore BC is equal to therefore BP is the path. Therefore BP is the path. Therefore BP is the path difference between two waves. From delta ABC, sin theta is equal BC by AB, or BC is equal AB sin theta. Putting AB is equal D. Hence the path difference BC between the wave reaches the point on the screen. Draw a perpendicular. Therefore, BC is the path difference between two. Therefore, BC is the path difference between two waves. Therefore, the BC is the path difference between two waves. Hence, added as from delta ABC, delta ABC sin theta is equal AC BC by AB BC by AC, or draw the perpendicular from A and B. Let's write it. Draw a perpendicular. Okay. Draw a perpendicular from A to P, BP, AP is equal CP. Therefore, BC, BC is the path difference, DIFFERENCE difference between the wave at point on the screen. From two slides. ABC. PC. Sin theta, putting hence the difference BC is equal D by sine theta, equation 1. Drawing a perpendicular from a draw a perpendicular from a from A on BP. AP is equal BP. From perpendicular from A on BP. A on BP. A on BP. Draw perpendicular from A on BP. AP is equal CP. AP is equal CP. Therefore, BC is therefore the point. Therefore, BC is the path difference between two sources. From delta ABC sine theta is equal BC by AB, or BC is equal AP sine theta, putting AB is equal D. Hence the difference between the path. Hence the path difference between the wave reaches a point P on the screen. From the two slide is path difference is equal D. BC is equal D sin theta. BC is equal D sin theta. Equation 1. Constructive interference occurs when a light wave series overlap, resulting bright maxima on a screen when a path difference is integer multiple on the wavelength. Construction interference occurs when light wave series overlap. Constructive interference occurs when light wave series overlap. Constructive interference occurs when light wave series overlap. Constructive interference occurs when light wave series overlap. Light wave series overlap. Constructive occur when light wave series overlap, resulting in maximum brightness screen. Maxima on a screen. The path difference is in an integer multiply on m by lambda. Path difference is equal m by lambda, or m by lambda. M by lambda is equal m by lambda. The constructive interference occurs when the light wave series overlap. Constructive interference occurs when the light wave series overlap, resulting in maximum bright maxima on a screen when the path difference is integer multiply on the wave. Path difference. Alright. بالله من الشيطان بسم الله الرحمن الرحيم. Thomas Young in 1801, Thomas Young performed the interfering experiment to prove the wave of nature of light. Thomas Young double slit experiment is the evidence for the wave nature. A screen having two narrow slides is illuminated by beam of monochromatic light. The principle of this experiment is based on the division of the wavefront in monochromatic light passes through the narrow slide producing semi-wave and overlap and interfere. The monochromatic light passes through two narrow slides producing semi-circular wave overlap and interfere on a screen placed behind the slide. As the two slides S1 and S2 are narrow, so the light spreads out, diffracting from each side. Two slides generate two coherent light sources, causing interference in furigance in the form of a bright constructed interference and the destructive interference pattern on the screen. As two slides S1 and S2 are narrow, so the light spreads out, deflecting each side. So the light spread out, deflecting each side. Two slides generate two coherent light sources, causing interference furigance in the form of bright constructive interference and dark pattern on the screen. Path difference. The wave from slide S2 has traveled slightly larger than S1 to reach the point P on the screen. The slide S2 has to travel slightly larger than from S1 to reach the point P on the screen. This difference in the difference in the distance is difference path. The phase difference between two waves is proportional. The phase difference between two waves is proportional to the terms is proportional to the path difference expressed in terms of wavelength lambda. The phase difference between two waves proportional to the path difference expressed in the terms of wavelength lambda. Okay, right. Thomas Young, THOMAS, Thomas Young experiment. Thomas Young experiment. In 1801, Thomas Young performed the interference experiment meant to prove wave nature of light, light. The Young's double slide, double slide experiment, double slide experiment, evidence of wave nature, a screen of I don't know, a screen of two narrow slides, two narrow slides, by a screen of two narrow slide. एक लफ्ज आता है, आई नो ये बीम, पता है बीम मोनोचोरो लाइट ऐसा कुछ है, इज इल्यूमिनेटेड, सॉरी, इज illuminated by a beam of monochromatic light. Path difference. Path difference. I don't know how to write this one. Path difference. अभी the principal वो वगैरह लिखा ही. The principle, principle of this experiment is based on, I don't know, monochromatic, based on division of wavefront monochromatic light chromatic passes through beam through to narrow slide split slide two narrow producing producing semicircular circular WAVE wave, semicircular wave. Semicircular wave. What else? Semicircular wave that can shown on the screen behind the slides. Behind the slides. अब अगला क्या है monitor S to slide S1 and S2 are narrow. S2 narrow slides are narrow. The LIGHT light is spread out. SPREAD spread out, diffracting. DIFFRACT diffracting. Each slide diffracting each slide. Two slides generate two narrow slide कर लें NARR narrow slide generate two coherent sources in a FOM form of bright 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 constructive interference and destructive and destructive. On the pattern on the screen. Screen, okay. Far difference. Path difference. The wave from. Okay, sorry. The wave from slide S1 S2 has to travel slightly SLIGHT and a slightly larger LARGR as compared to as larger than then that from S1 slide to reach the point P, reach to the point with the difference between the distance is the phase difference between two narrow split side is proportional to the terms is proportional to the path difference difference between path difference in terms of in terms of wavelength lambda half-life. What else? I don't know. Graph. The distance, the separation distance between slides is equal A, B is equal D. Okay. Distance between slides and the point P Draw perpendicular. Draw perpendicular. AP is equal CP. The path difference difference is equal क्या कहते हैं D is equal BC by AB. The path is between two narrow slides reaching the point P on the screen. Reaching point pi on SCREEN. Okay, what else? I don't know. Think. Sin theta is equal BC by AB or BC is equal AB sin theta. Hence, path difference BC is equal sin AB sin theta AB. Equation 1. D sin theta, sorry. Putting PUTTING, putting AB is equal D. D sin theta. The perpendicular form draw perpendicular from A on BP. Draw a perpendicular A from B and P. A from B and P. AP is equal CP. ये तो मैंने लिख लिया. From therefore BC is the path difference between two waves. Therefore BC is the path difference between two waves. Therefore BC is the path difference between two waves. Two difference from delta ABC. Hence the path difference between the wave reaches the point on the screen of from two slides. Draw a perpendicular from A and P. Draw a perpendicular from A on BP. Perpendicular from A on BP. A on BP. AP is equal CP. Therefore BC is the path difference between two waves. Therefore BC is the path difference. BC is the path difference from. Therefore BC is the path difference. Therefore BC is the path difference. Therefore BC is the path difference between. Therefore BC is the path difference. Therefore BC is the path difference between two waves. Therefore BC is the path difference between two waves. Therefore, BC is the path difference between two waves from delta ABC. Delta is BC sin theta is equal BC by AB, or BC is equal sin theta, AB sin theta, AB is equal D. Hence, path difference BC is equal D by sin theta. Equation 1. Indeed. The path difference of the path difference. Therefore, the BC is the path difference between two waves from ABC sin theta is equal BC AB, or BC is equal AB sin theta, putting AB is equal D. Hence, the path difference BC between the two waves reaches the point on the screen from the slide is the path difference is equal BC by D sin theta. Hence the path difference between the wave, the path difference between the wave, hence the path difference between the wave, hence the path difference between the wave reaches the point on the screen from two slide is path difference is equal I have to take a piss, mate. Take a break. Okay. Alright. Let's start. أعوذ بالله من الشيطان بسم الله الرحمن الرحيم ربي يسر ولا توسر وتمن خير آمين يا رب العالمين. Thomas Young performed the interference experiment to prove the natural wave of light. 1 minute. Alright, it's recording. After double checked. Thomas Young performed two sort experiment. Thomas Young interference experiment to prove the natural wave. Thomas Young performed the interference experiment to prove the wave of natural light. Thomas Young double slide is evidence for the wave of natural light. A screen having two narrow slides is illuminated by the beam of monochromatic light. The principle of this experiment is based on division of wave front. The monochromatic light passes through two narrow slides, producing semicircular wave that overlap and interfere on a screen placed behind the slide. Monochromatic light passes through two narrow slides, producing semicircular wave that overlap and interfere on a screen placed behind the slide. Monochromatic light passes through two narrow slides, producing semicircular wave that interfere and overlap on a screen behind the slides. As two narrow slides S1 and 2 are narrow, so the light spread or diffract from each slide. Two slides generate two coherent light sources, causing interference variance in the bright form as the two slide S1 and S2 are narrow, so the light spread or diffract from each slide. Two slides generate two coherent light sources, causing interference variation in the bright constructing interference and dark destructive interference path pattern on the screen. Path difference. The wave from S2 has to travel slightly larger than the wave from slide S2 has to travel slightly larger than S1 to reach the point P on the screen. The difference from the difference in the distance is the path difference. The phase difference between two waves proportional to the path difference expressed in the terms of wavelength lambda. Separation between two slides AB is equal D. Distance between the slide and the screen L. Distance between point from the center on the maximum is equal Y. Draw a perpendicular from A on B, A and B, A on BP, AP is equal CP, AP is equal CV. Therefore, BC is the path difference between two waves from delta ABC. Sin theta is equal BC by AB, or BC is equal AB by sin theta. AB is equal D. Hence the path difference BC between the wave. The path difference BC between the wave reaches the point. The path difference between the wave reaches the point. The path difference between 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 WAVE wave. The path difference BC. The path difference BC between the wave reaches the point of the path difference BC between the wave reaches the point. Between the wave reaches the point, the path difference BC and the wave reaches the point. The path difference BC between the wave reaches the point, reaching a point on the screen, reaching a point on a screen from a two slide is path difference equal BC is equal D by sin theta. Equation 1. Constructive interference occur when light wave. Constructive interference occur when light wave series overlap. When light wave series overlap. Constructive interference occur when light wave series overlap. Constructive interference occur when light wave series overlap, resulting bright maxima on the screen. When the path difference is integer multiply on the wavelength. Integer multiply by wavelength. Constructive interference occur when the light interference. Constructive interference occur when light wave series overlap. When the light wave series overlap. Constructive interference occur when light wave series overlap, resulting in bright maxima on the screen. Constructive series overlap. Constructive interference overlap. Constructive interference occur when the light wave series overlap, resulting bright maxima on the screen. When the path difference is integer multiplied by the wavelength. integer multiplied by wavelength. Series series constructed interference occur when light wave series overlap, creating resulting bright maxima on screen when a path difference is integer multiply on the wavelength. Series interference occur when light wave series overlap, resulting bright maxima on the screen when the path difference is integer multiply on the wavelength. Constructed interference occur when constructive interference occur when light wave constructive interference occur when light wave series overlap, resulting bright maxima on screen when path difference is integer multiply on the wavelength. Constructive interference occur when light wave series overlap. Occur when light wave series overlap resulting in bright maxima series overlap. Constructive interference occur when the series of constructive interference occur when the light wave series overlap, resulting maxima on the screen. Constructive interference occur when the series overlap, resulting in bright maxima on the screen when the path difference is integer multiplied by wavelength. Constructive interference occur when light wave series overlap, constructive interference occur when the light wave series overlap, resulting bright maxima on screen when the path difference is integer multiplied on the wavelength. Constructive interference occur. Constructive interference occur when wavelength. Constructive interference occur when light wave series overlap. Constructive interference occur when light wave series overlap. Constructive interference occur when light wave series overlap, resulting in maximum bright maxima on screen when the path difference is an integer multiply on the wavelength. Constructive interference occur when light wave constructive interference occur when light wave series overlap, resulting in bright maxima on screen when the path difference is integer multiply on wavelength. By wavelength. Constructive interference occur when the light wavelength series overlap, Constructive interference occur when light series overlap, waves series overlap, resulting in bright maxima on the screen, resulting in bright maxima on screen. Series interference occur when constructive interference occur when light wave series overlap, resulting bright maxima on screen. Constructive interference occur when light wave series overlap, resulting bright maxima on screen when the path difference is integer multiply on wavelength. resulting interference occur when light wave series overlap, resulting bright maxima on screen. When the path difference is an integer multiplied by wavelength, integer multiplied by constructive interference occur. Constructive interference occur when light wave series overlap. When light wave series overlap. Constructive interference occur when light wave series overlap, resulting in maxima on screen. When constructive interference occur when light wave series overlap, resulting bright maxima on screen. When the path difference is integer multiplier on the wavelength. When the path difference is integer multiplier on the wavelength. When the path difference is an integer multiplied by wavelength multiply of the wavelength. Constructive interference occur when light wave series overlap, resulting in bright maxima on the screen. When the path difference is an integer multiply on wavelength. When the path difference is an integer multiply on the pattern of the wavelength. Integer multiply of the wavelength. Constructive interference occur when light wave series overlap, resulting bright maxima on screen. When the path difference is integer multiply of the wavelength. The path difference. Constructive interference occur when constructive interference occur when light wave constructive interference occur when light wave series overlap, resulting in bright maxima on the screen. When the path difference is an integer of wavelength. Series interference occur when the wave. Constructive interference occur when series overlap. Constructive interference occur when light wave series overlap. Constructive interference occur when light wave series overlap, resulting in bright maxima on the screen. When the path difference is integer multiply of the wavelength. Integer multiply of the wavelength. Constructive interference occur when light wave series overlap, resulting in bright maxima on the screen. The path difference of integer multiply is wavelength of the wavelength is an integer multiply. When the path difference is an integer multiply of wavelength, path difference is equal m lambda. Path difference is equal m by lambda, or d sin theta is equal m by lambda. Equation 2. When m is an integer, 0, plus minus 1, plus minus 2, plus minus 3 is represented. Constructive interference occur. When light wave series overlap, resulting in bright maxima on screen. When the path difference is an integer multiply on the wavelength. Path difference is equal m by lambda, or d sin theta is equal m by equation. Constructive interference occur when light wave series overlap, resulting in maxima on the screen. When the path difference is integer multiply on wavelength, path difference is equal m by lambda, or d sin theta is equal to m lambda equation to n lambda equation. Constructive interference occur when light wave series overlap, resulting in maxima on screen when the path difference is an integer of the wavelength. Constructive interference occur when light wave series overlap, resulting bright maxima on screen. Constructive interference occur when light wave series overlap, resulting in bright maxima on screen when the path difference is an integer multiplier of wavelength. Path difference is equal m by lambda d sin theta is equal m by lambda equation 2 where m is constructive interference लिखते हैं फिर. Constructive interference occur when series overlap. आगे लिखते हैं occur when light wave light wave series overlap, resulting in constructive bright maxima on screen. Bright maxima on screen. Okay. When the path difference आगे क्या आता है? When the path difference is an integer multiplier is an integer multiply of an wavelength of a wavelength path difference difference is equal m by lambda d sin theta is equal m by lambda. Equation 2. When m is an integer, when m is an integer, m integer को कहते हैं, okay, m integer multiply 0 1 negative 0 plus minus 1 plus minus 2 plus minus 3 representing the order of maximum central maximum represent order when m is the integer 0 plus minus 1 plus minus 2 plus minus 3 up to so on, represent the order of maximum. Central maximum is 0 order. When m is equal plus minus 1, the two bright fragments are obtained, one above and one below the central point 0. When are called first order bright series. When m is an integer, when m is an integer 0 plus 1 plus minus 1 plus minus 2 plus minus 3 up to so on, represent the order of maximum. Represent the order of maximum. Represent the order of maximum. When m is an integer of 0 plus minus 1 plus minus 2 and plus minus 3 up to so on, represent the order of maximum. Center maximum is 0th order. When m is the integer 0 plus minus 1 plus minus 2 plus minus 3 up to so on, represent the order of maximum. Central maximum is 0th order. When m is equal plus minus 1, when m is equal plus minus 1. When m is the integer, an integer plus minus 0 plus minus 1 plus minus 2 plus minus 3 up to so on, represent the order of maximum. Central. When m is an integer of plus minus 1 plus 0 plus minus 1 plus minus 2 plus minus 3, the represent of the maximum series. When m is an integer 0 comma plus minus 1 plus minus 2 plus minus 3 up to so on, represent the order of maximum. Represent the order of maximum. Center maximum is 0 order. When m is an integer 0 plus minus 1 plus minus 2 plus minus 3 up to so on, represent the order of maximum. The center maximum is 0th order. If integer plus minus 1, when m integer is equal plus minus 1, then two bright fragments are obtained. Then two bright fragments are obtained. When two when an integer when m is an integers, when m is integer 0, comma, plus minus 1, comma, plus minus 2, comma, plus minus 3, 2, 3, up to so on, representing represent, representing the order of maximum, the order of maximum, maximum, when m is an integer, 0 plus minus 1 2 3 up to so on, represent the order of maximum, center maximum, the center, CENTRA, central maximum, MAXIMUM, maximum is zeroth order, order, when m integer is equal plus minus 1 to bride Farigans, FRINGS, gens, Farigans, FRIGE, FIR, Farigans are obtained, obtained, TAINED, obtained, are obtained, one above, ABOV, above, and one below, BELLO, below the central point, the CENTRAL central point, point 0, point 0, comma, which are the first, which are called first order of BRIGHT, bright Farigans, yeah. When m is an integer, 0 plus minus 1 plus minus 2 plus minus 3 up to so on, representing the order of maximum, 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 representing the order of maximum. When constructive interference occur, when light wave series overlap, resulting in bright maxima on the screen, when the path difference is an integer multiply of the wavelength, path difference is equal m lambda, or path d sin theta is equal m lambda 2, when the m is the integer, plus minus 0 plus minus 1 2 3 4 1 2 3 up to so on, representing the order of maximum, resulting in order of maximum, resulting in order of maximum, center maximum is order is 0 order, when the m is the integer, 0 plus minus 1 2 3 4 are representing the order of maximum, resulting in the order of maximum, resulting in center maximum is zeroth order, when m integer is equal plus minus 1, two Brighton Farigans, then the two Brighton Farigan are obtained. The two Brighton Farigan are obtained one above. Then two Brighton Farigan are obtained one above. The two Brighton Farigan when two Brighton obtained are Farigan. When two Brighton Farigan are obtained. When two Brighton Farigan are obtained above. 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 When two Brighton Farigan then the two Brighton Farigan are obtained above and one and above the central point 0 when m is equal plus minus 1, then two Brighton Farigan are obtained. Two Brighton Farigan are obtained one above. Then two Brighton Farigan Farigans are obtained above one and above one and one above and one below the central point 0, which are first order of bright Farigans, which are the first order of bright Farigans. When m is equal plus minus 1, then two Farigans are obtained above 1. Two Farigans are obtained above 1. When m is equal plus minus 1, then two bright Farigans are obtained one above one below the center, obtained one above one below the central point 0, which are called order bright Farigans. Constructive interference. यहाँ से लिख. When constructive interference constructive interference occur when bright light wave के आगे क्या आता है? I don't know. सोचता रहे. I really don't know. When the light wave Farigans नहीं constructive interference occur when light wave serious overlap resulting resulting in bright bright maxima on screen on screen on SCREEN screen bright maxima on screen when the path difference difference when the path difference is an integer multiply is an integers multiply of a wavelength length. Direct लिख ले equation 2 d sin theta is equal m lambda. Equation 2 when m is an integers 0 plus minus 1 plus minus 2 up to so on, representing the order of the maximum maximum के आगे क्या आता है? maximum comma central maximum CENTRAL central maximum 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 0 order comma 0 order I don't know 0 order when m is equal plus minus 1, then to brighten to BRIGHT bright फरिजन्स एक अबव है ना, क्या कहते हैं? फरिजन्स आर obtained 1 above 1 below 1 above and 1 below 0.0 comma which is first order of bright farigens. Okay, I'm taking a break. Now let's check is it worth it or not. Destructive interference happens when the series of the one wave cancel out each other. Amen. Constructive interference occur when light wave series overlap, resulting in maximum on bright maxima on screen, bright maxima on screen, bright maxima on screen. Constructive interference occur when light wave series overlap, resulting in bright maxima on screen, bright maxima on screen, bright maxima on screen, bright maxima on screen, bright maxima on screen when the path difference is an integer multiplier of the wave. Path difference is equal m by lambda, or d sin theta is equal m lambda, where m is the integer 0 plus minus 1 plus minus 2 plus minus 3, representing the order of maximum. Central maximum is 0 order when m is equal plus minus 1. Then two bright farigens are obtained above and below the central point 0, which are called first order of bright farigens. Constructive interference occur when light wave series overlap, resulting bright maxima on screen. When when path difference is integer, integer multiply on wavelength. Path difference is m lambda integer lambda क्या होता है wavelength और d sin theta is equal m lambda equation 2 where m is an integer 0 plus minus 1 0 plus minus 2 plus minus 3 up to so on, representing the order of maximum representing the order of maximum. They are representing the order of maximum. Central maximum is 0 order when m is equal plus minus 1 then two bright Farigans are obtained, one above one below, and center is 0, which is called first order of bright Farigan. Destructive interference happens when the series of one wave cancel out through the another, resulting in dark minima. Destructive interference occur when destructive interference happens when series cancel out each other, one another, one of series of one wave cancel out each other, through of another, resulting resulting in a dark minima. This occurs when the path difference is an odd path difference. Difference is an odd multiplier multiplier of half the wavelength length, I dot e path difference path difference is equal m plus 1 by 2 lambda or d sin theta is equal m plus 1 by 2 lambda equation 3. The destructive interference happens when the series of one wave cancel through another, cancel the torque of other. Series interference happens when the series destructive interference happens when the series of one wave cancel out the torque of another, resulting in black resulting in dark minima. The structural interference happens. The structural interference happens when series of one wave cancel out through another, cancel out the torque of another. The structural interference occurs. The structural interference happens when the series of one wave cancels out the torque of another. The structural interference happens when the series of one wave cancel out destructive interference happens when the series of one wave cancel out torque of another, resulting in dark minima. This destructive interference happens. Destructive interference happens when series of one wave cancel out through torque of another. Destructive interference happens when series of one wave cancel out the torque of another. Series of one wave cancel out the torque of another, resulting in black minima. This occurs when the path difference is odd's multiply of the half the wavelength. This occurs when the path difference is an odd multiply of half the wavelength. This path difference occurs This certain inference happens when the series of one wave cancel out the torque of another, resulting in a dark minima. This occurs when the path difference is odd multiply of the half of the wavelength. This occurs when the path difference is an odd multiply of half the wavelength. Half of the wavelength. Path difference is equal m is equal integer m 1 by 2 lambda, or d sine theta is equal m plus 1 by 2 lambda, equation 3, where m is still an integer 0 plus minus 1 plus minus 2 plus minus 3 up to so on, representing the order of minima. इसमें maxima representing the order of minima. First minima m is equal 0, second minima m is equal 1, और third minima is equal m is equal 2. ठीक है. Here m is still integer 0, plus minus 1, plus minus 2, plus minus 3 up to so on, representing the order of minima. Minima. For first, minima is equal 0, second minima is equal plus minus 1, third मिनिमा क्या होता है? थर्ड मिनिमा प्लस माइनस 2 और ये स्ट्रक्चरल इंटरफेरेंस आकर structural interference as well. Position of maximum and minima. Let P right. Destructive happens happens when thrust of one wave cancel out the torque of another resulting resulting in a dark minima dark minima on this occurs when integer multiply half odd half multiply of half of wavelength of wave length यहाँ तक हो गया। आगे होता है okay, now what? क्या लिखा? पावर डिफरेंस F is equal m plus 1/2 लैम्डा। ठीक है, आगे क्या आता है? आई डोंट नो। d sin थीटा is equal m plus 1/2 लैम्डा। इक्वेशन 3 आगे क्या आता है? m is still the integer 0, plus minus 1, plus minus 2, plus minus 3. representing order of representing order क्या कहते हैं I don't know representing order of minima comma first minima is equal 0, second is equal plus minus 1, third is equal plus minus 2. Diffraction interference याद हो गया. Position of maxima and minima. Put P is the position of mth order integer order bright variance on the screen. Then d sin theta is equal m lambda. If theta is very small, then sin theta is equal tan theta. So d tan theta is equal integer lambda m integer lambda. F tan is equal y by l. Tan is equal y by l. Okay, y by l ठीक है 1/2 I don't know y by l क्यों लिखा है y by l d y by l tan theta is equal y by l d y by l is equal m by lambda. Y is equal or y is equal m lambda l d equation 4. Let P is the position of mth order variance on the screen, then m order variance on the screen, then let P is the position of m order bright variance on the screen, then m order of variance screen, then let P is the position of mth order bright variance on the screen, let P is the position, then let P is the position of m order, then m order, then let P is the position of m order, then let P is position maximum position of maxima and minima. Let P is the position of mth order brighten variance on the screen, then maximum position the position of maxima and minima, position of maxima and minima, position of maxima and minima. Mini lights. Let P let P be the position of mth order bright Fergens BRIGHT bright Fergens French on the screen, then d sin theta is equal m lambda sin theta is so small. Now देख sin theta is so small, then sin theta is equal tan theta, hence so comma d tan theta is equal m lambda tan theta is equal y by L, so dy by L is equal m lambda or y is equal m by lambda L by D. Equation 4. y is equal m lambda L m lambda L D. Equation 4 gives the distance of m. Equation 4 gives the distance of L. Let the P is the position of m. Order bright Fergens on the screen. Then order brighten screen, and then let P is the position of m. Order brighten screen. Then how long is it? Brighten screen, then let P is the position of m. Order brighten screen. Then order brighten screen. Then let P is the position of mth. Order brighten Fergens screen on screen. Then order bright Fergens Ferens then Fergens बोल दे, क्या जाता है Fergens on the screen. Then d is equal d sin theta is equal lambda by m by lambda. Okay, so small, very small, then sin theta is so small, then blah blah blah. Okay, so d is equal theta m by lambda. Okay, tan theta is equal y by L. Y क्या है? L क्या है वो तो पता है, L वैसी P है, क्या कहते हैं distance between slide and point, और y है क्या कहते हैं distance of क्या कहते हैं p from center, point p to center. Okay, so d is equal m by pi और y is equal m lambda L by d. Equation 4. So equation 4 gives the distance of m. So equation 4 gives the distance of L. So equation 4 gives the distance of L. So equation 4 gives the distance of L. So equation 4 gives the distance. So equation 4 gives the distance of L. So equation 4 gives the distance. So equation 4 gives the distance of L. So the equation 4 gives the distance. So equation 4 gives the distance of L. So the equation 4 gives the distance of L. So equation 4 gives the distance of mth bright Farigans from the screen. So equation 4 gives the distance of mth bright Farigans from the screen. Bright Farigans from the screen. From center of screen. Equation 4 gives the distance of mth Farigans from the Farigan m from distance of m bright Farigans from the center of screen. Similarly, for the position of mth order Farigans on the screen, we can get equation 4 gives the distance of mth bright Farigans from the center of screen. Equation 4 gives the distance of mth bright Farigans from the center of screen. Equation 4 gives m dark Farigan. Equation 4 gives m dark Farigan. Equation 4 gives m dark Farigan. Equation 4 gives the distance of the mth bright Farigans from the center of screen. Equation 4 gives the distance m bright Farigan from center of screen. Similarly, the position of mth order dark Farigans on screen, we get y is equal m plus 1 by 2 lambda L by d. Equation 5. This equation allows to calculate the position of maxima and minima on the screen based on knowing that this equation allows to calculate the position of maxima and minima on the screen based on knowing the value of d and lambda. Note the center maxima. Note that the center of maxima is m is equal to 0 and y will always be 0. M will be 0, y will be 0. Call it off, yaar. Yep, calling it off.